Hey guys, we will be discussing problem A2 of round 1 of this year's Facebook Hacker Cup. The problem goes like this. There is a child whose teacher have given him a typing task. So that typing task consists of a typing a string. This string contains letters F, O and X only. He types with one hand at a time. His left hand reaches till F and O letters only. On the other hand, his right hand reaches till letters F and X only. So to type the whole string he might need to switch his hands multiple times. We will need to find out the minimum hand switches which will be required for typing all the substrings of the given string. We need to solve this in linear space and time complexities. I highly recommend you guys to take a look at the problem given in the description of this video and try it out first on your own. Here we will be discussing approach for solution now. So let's jump in. For the solution, let's see an example first. We are given a string here. The letters F do not cause switches here. Remember that. Only X and O are responsible for switches. So I have highlighted them with orange color. All O letters to the right of the highlighted O will not cause any switch since he is already using the left hand in this case. Hence, switch occurs when we reach highlighted O. Let's call this an inflection point. Now let's calculate all the substrings which includes these highlighted letters and cause only one switch. So let's start with the simplest substring. We started from X and ended at O. So this will cause only one switch and this is the simplest substring. Now we can extend this substring to the right, include the F, still our switches remain 1 and our substring changes. Similarly, we can go to the end of this array and still our switch will remain 1 and we will reach 5 such substring when we extend it to the right of O. Similarly, we can extend it to the left of X. Here, if you see, if we include F, it doesn't change the number of switches. So in this case, we get 4 such substrings to the left of X where we have only one inflection point or one switch. Now answers for this substring becomes this. Switches into L into R, which is here 20. If you see, we did not cover other substrings. This is because all other substrings will have 0 switches and the max number of switches in the whole array is only 1. Thus, we calculated effectively the total number of hand switch he will require for all substrings of this array. Now let's see what happens near inflection points. In this example, I have marked inflection point with this red color. Now, we don't consider X and O's which are away from the inflection points. Why? Because they do not directly contribute to the inflection and the switches. So all the red marked X's do not contribute in any switch since there is already an X right to them. Similarly, we will only consider X and O's which are closest to the inflections for our L and R values because X's which are in the red boxes will not be directly contributing to our inflections. These will be covered inside the L values of our yellow X, which is nearest to the inflection point. Similarly, the nearest O to the inflection point, which is inside the yellow box, will contribute its R substrings for these red colored boxes of O's to the right of it. Now let's see some bigger example. We will count switches here. So we start from X. We won't require any switch here. Now we jump to F and then O. So we will require one switch here, then to X, then again we will require 2 switches here. Now to index 6 at O, we will require 3 switches. Similarly at X at 8, we will require 4 switches. Until the end, we can see we will require total number of 6 switches in this array. So now let's pay attention here that the orange color indices are the original indices of the string and the pink indices are the ones where inflection comes around. So now what we will do, we will start from the leftmost X and we will try to solve out for all the substrings which will cover this X at the index 0. We will start from the leftmost index 0 which has X and we can extend our substring till O for the one switch. So till O we will have only one switch and the R1 value of this first inflection point is 2 here because after O we can go till F without adding another switch. Similarly, we will extend our substring till X. Now we will have 2 inflections because again from O we will need to switch to X. Now for this the answer will be 2 into L0 into R2. R2 here is the Maximum the substring can go from X till we don't increase the number of switches. Similarly to O at the inflection point 3, the answer will be 3L0 R3. Here R3 is also equal to 2. Similarly for another X at the inflection point 4, we will have 4 into L0 into R4. Here R4 again is the maximum amount we can stretch without increasing number of switches. Now for the fifth inflection point, we will have 5 switches. So again 5 into L0 into R5 will be the answer for this. Now in the last we have only one X. So this will cost our 6 switches. So it will be 6 into L0 into R6. Here R6 will be 1 because we can't go beyond this X. Similarly, if you calculate answer of 1, that means if you start from the O, your answer will be like this. Again, after simplifying the answer 0, you will see that you can take common L0 value and then you can multiply other values by having the summation of this. Similarly, answer 1 can also be simplified by taking L1 as common value and then there is a multiplication of things inside that and sum of them. Also to note here, the L0 is only 1 here because we can't go left to our 0th index, which is X. So it will always remain 1 and we can't have any element to left of it to extend the substring to the left of X. Assume we already have L values and R values calculated for all the inflection points. We will actually see in later part of this video how to calculate them efficiently. For now, let's look how our generic solution will look like. Say we were considering the answer of 0 equal to L0 into 1 plus R1, 2 into R2 and so on. Similarly, answer 1 is equal to L into 0R1 plus 1R2 plus 2R3. Now the coefficient of these L0s and L1 and L2, we can consider them as some other variables, say some 0 and some 1. Now we will replace them with this some 0 and some 1 and some 2. Now we want to find out what is the relation between sum 0 and sum 1. You can see if we subtract sum 1 from the sum 0, we will see our value will become like this. This is nothing but the summation of all the inflection points which we have. Similarly, if you subtract sum 2 from sum 1, we will see this will be our value, which is summation till R2. And this is the suffix sum. So we can say that sum 1 equal to sum 0 plus summation of all ri's. Similarly, sum 2 equal to sum 1 plus summation of all ri's except the R1. That means the suffix sum of all r's till the I equal to 2. And our final answer will be the sum of all these answers. Answer 0, answer 1 and answer 2, etc. for all the inflection points which we have. Now we will calculate L values and R values for this array. So for leftmost index X, we have L0 equal to 1 because we can't go to the left of it. Now for the first inflection point for O, the L values simply can be calculated by current minus previous index. Remember, these are the original indices. So this will become 2 minus 0. Now for the L2, we can again go to one left only till F. So again, this is current minus previous, which is 2. Now this is the interesting case for L3. For L3 we have the L2 as well because it is same. We have X same as L2 which is at L3. So same X's are there, so we can add up these values. So it will be L2 plus current minus previous, so this will become 6. Similarly for L4 we can calculate current index minus previous index, which is 2. Similarly for L5 we can move only 2 substrings left to our X. So similarly, you can go from right to left to calculate R values. These are exactly similar. Now we just saw that we can calculate these L and R values in linear time complexity only. So we can conclude that our answer will be here in linear time complexity only. Yeah, so that's it for this video, guys. Thanks guys for watching this video. If you have any doubt, please comment down below.